What is electric dipole? Question mark. Write its SI unit and direction. An electric dipole is a system of two equal 2A bracket and opposite point charge plus q and minus q separated by a finite distance. If 2A is the distance between two charges q and minus q, the dipole moment of this system is given by vector p is equal to q in bracket 2A vector bracket over electric dipole moment is a vector quantity. Its direction is pointing towards the positive charge. You can see in figure also minus q and plus q charge. Dipole directed towards the positive charge. The distance between both the charges is 2A from the center, that is A and A. The unit of the electric dipole is coulomb into meter and ampere second into meter. Its dimension formula is m0 L1 T1 A1 and m0 L1 T0 Q1. Total charge of the dipole system is 0, but its electric field is non-zero because two opposite charges are situated at different places. What is point dipole? Question mark. If limit 2A vector tends to 0 in vector p is equal to 2A vector q, then the electric dipole is called point dipole. Obtain the equation of electric field by dipole at a point on axis of dipole. Let the point P be at distance r from the center of the dipole on the side of the charge q as shown in the figure. The distance between electric charge plus q and minus q is 2A. You can see in figure. The electric field by minus q charge vector E minus q charge is equal to minus q upon 4 pi epsilon 0 in bracket r plus a bracket over square into unit vector p is equal to minus kq upon bracket r plus a bracket over square unit vector p. Distance from minus q to p is equal to r plus a, that is equation number 1. Now electric field by plus q charge, that is electric field E for plus q is equal to minus q upon 4 pi epsilon 0 in bracket r minus a bracket over square into unit vector p is equal to minus kp upon bracket r minus a bracket over square into unit vector p. A distance from plus q to p is equal to r minus a, that is equation number 2. The total field at point P, you can see in figure, that is vector E is equal to vector E plus q minus vector E minus q is equal to kq bracket 1 upon bracket r minus a bracket over square minus 1 upon bracket r plus a bracket over square bracket into unit vector p. From equation 1 and 2, E is equal to kq in bracket r square plus 2ar plus a square minus r square plus 2ar minus a square upon bracket r square minus a square bracket over whole square bracket over into unit vector p. Therefore E is equal to, now you can see here a square cancel and r square cancel. So finally vector E is equal to kq in bracket 4 pi r upon in bracket r square minus a square bracket over square in next bracket into unit vector p, equation number 3, is equal to k in bracket 2 p r upon bracket r square minus a square bracket over whole square bracket over into unit vector p, where p vector p is equal to 2a into q unit vector p. Therefore for r greater than a, then r square minus a square is equal to r square using this equation in 3. Therefore vector E is equal to k 2p vector upon r cube is equal to 2p vector upon 4 pi epsilon 0 r cube. Therefore, vector E is equal to 2kp vector upon r cube. Obtain the equation of electric field by dipole at a point on an equator of dipole. Distance of point P from plus q and minus q are same. Therefore, r plus is equal to r minus is equal to under root r square plus a square, where r is equal to distance of P from O. The magnitude of the electric field due to the two charges plus q and minus q are equal. Therefore, E plus is equal to q upon 4 pi epsilon 0 1 upon r square plus a square is equal to k q upon r square plus a square, equation 1. Similarly, E minus q is equal to q upon 4 pi epsilon 0 1 upon r square plus a square is equal to k q upon r square plus a square, equation number 2. The direction of vector E plus and vector E minus q are shown in the figure. You can see in figure the two charges plus q and minus q at a distance of 2a, and point P from midpoint of both the charges, that is O to that is r distance, and the distance between P and plus q and P and minus q is under root r square plus a square. Now here due to plus q charge, the field, that is E vector E plus q, and the field due to minus q charge is equal to vector E minus q. E plus q charge has two components, that is E plus q cos theta horizontal direction and E plus q sin theta in y direction. Similarly, E minus q cos theta horizontal direction and E minus q sin theta in towards the midpoint. Now you can see here the triangle, that is P plus q minus q, and three sides that is here given, that is O plus q is A, then OP is R, and plus q and P, that is under root r square plus a square. Now you can see here the E plus q cos theta and E minus q cos theta both are in same direction, but E plus q sin theta and E minus q sin theta are opposite to each other, so their effect is 0. The total electric field at point P vector E is equal to minus E plus q plus E minus q cos theta into unit vector P is equal to minus 2kp is equal to minus 2kq upon r square plus a square cos theta into unit vector P, equation number 3. Perpendicular component of the dipole axis of vector E plus q and vector E minus q at point P are E plus q sin theta and E minus q sin theta. They are equal in magnitude and opposite in direction, so they will cancel the effect of each other. But parallel component of the dipole axis of vector E plus q and vector E minus q at point P are E plus q cos theta and E minus q cos theta, and they are in same direction, so they will be added. As a result, vector E will be in opposite to unit vector P. Therefore, vector E is equal to minus in bracket E plus q cos theta plus E minus q cos theta bracket over into unit vector P is equal to minus 2 E plus q cos theta unit vector P. Here E plus q is equal to E minus q. Therefore, vector E is equal to minus 2kq upon r square plus a square into cos theta into unit vector P. Now, from the figure, cos theta is equal to a upon in bracket r square plus a square raised to 1 by 2. From the equation 4 and 5, this is equation number 5. From equation 4 and 5, vector E is equal to minus 2kq upon r square plus a square into a upon in bracket r square plus a square bracket over raised to 1 by 2 into unit vector p. Therefore, vector E is equal to minus 2kqa upon in bracket r square plus a square bracket over raised to 3 by 2 into unit vector p. If r greater than a, then a square can be neglected. Therefore, vector E is equal to minus 2kqa upon r cube into unit vector p. But vector p is equal to q into 2 into vector a into unit vector p. Therefore, vector E is equal to minus k vector p upon r cube into unit vector p, or vector E is equal to minus p upon 4 pi epsilon 0 r cube into unit vector p. Important topic. First, at very large distance, electric field of the dipole varies as 1 upon r cube and not like 1 upon r square. Second, magnitude and direction of the electric field depends on angle between vector r and vector p.